Okay, the first video is about midpoint and distance formulas. Alright, this distance formula, if you recall from geometry, came from Pythagorean theorem, which you learned about a long time ago. If you recall, it said a squared plus b squared equals c squared. And with a lot of manipulation, we came up with the distance formula. If you don't remember all that, that's okay. I just want you to remember it came from Pythagorean theorem. Number one, using these endpoints, find the length of each side of the triangle. Determine if it's a right triangle. Okay, so I'm going to name these points A, B, and C, and I'm going to graph them. That's the very first thing I need to do is graph them. Get a look at what this actually looks like. Okay, so for point A is at 2, 1. Point B is at 4, 0. And point C is at 2, 5. Here's my triangle. Alright, there it is. Gives me an idea what it looks like. Now, what's handy about this, my goal here is to find if it's a right triangle, right? So I need to know the length of each side. Well, I look and see if any of these sides line up right with the grid. Well, this side right here does, so which means I can count just the boxes to find the length. I don't have to go through the mess of just the distance formula. I can count 1, 2, 3, 4. So this side is 4. Well, let's label our points. I didn't label, did I? A, B, and C. So I know that AC has a length of 4. Okay? So for AB, I need to work the distance formula. Okay? Using the points A and B, I'm going to just plug in x2 minus x1. Take the second x, subtract the first x. So 4 minus 2 squared plus, now do the y's, 0 minus 1 squared. 4 minus 2 is 2. If I square it, I get 4. 0 minus 1 is negative 1. If I square negative 1, remember that's a positive 1, so I get a 5 under the radical. So it's the square root of 5. So I know that AB is the square root of 5. Now I know AC, I know AB, so now I need to find out what is CB, that long side there. So I'm going to walk through the distance formula again using the points C and B. Doesn't matter which one you use first or second, just keep them in order. So 2 minus 4 squared plus 5 minus 0 squared. 2 minus 4 is negative 2. If I square that, I get a 4. 5 minus 0 is 5. If I square that, I get 25, right? So under my radical is the square root of 29. That's not a pretty number. We're just going to leave it as the square root of radical. We're just going to leave it under the radical just like that, unsimplified, because you can't really simplify it. Now we're on to the next part. Determine if it's a right triangle. Okay, so a squared plus b squared equals c squared. Well, you got to decide which of these three sides is the longest side. Well, 4 square root of 5 is a little more than 2, right? You know that 2 times 2 is 4, 3 times 3 is 9, so it's between 2 and 3. Square root of 29, if I took the square root of that, it's definitely more than 3. So what I can write is this: 4 squared plus the square root of 5 squared, is it equal to the square root of 29 squared? That's my goal here. Because if it is a right triangle, a squared plus b squared equals c squared. All I had to do is make sure that c was my longest side before I plugged it into my good old Pythagorean theorem, okay? So let's run the math here. 4 squared is 16. Square root of 5 times square root of 5 is 5. What's the square root of 29 times square root of 29? It's 29. Well, 16 plus 5 is 21. Is it equal to 29? No. Not equal to 29, so this is not a right triangle. Okay? Not a right triangle. If it were a right triangle, remember these two would be the same. Alright? Sometimes you might do a problem and it looks exactly like a right triangle, and you know it's a right triangle from the picture, but you've got to prove it using the Pythagorean theorem. Alright? That's what you need to know about distance formula. Alright, midpoint formula. If you remember the midpoint formula from geometry, this is when you find the middle of a segment. Okay? You have two endpoints. We'll call them A and B. And you're going to find the middle of it. Okay? Your goal is to use this formula. Notice it's just the x-coordinates added together divided by 2. And the y-coordinates added together divided by 2. That's all you have to do. First thing I'm going to do is plot my points and draw the segment that I'm talking about. So 2, 5 is way up here. 6, -3 is down here. Okay? Now, if I can draw a line, there's where it is. My goal is to find the midpoint algebraically. That's the first thing I need to do. And then I'm going to check my work graphically, see if it works, if it graphs right in the middle of this segment. So to do this, I'm going to take first my x-coordinates and add them up. So 2 plus 6 divided by 2. That's going to be my midpoint x-coordinate. For the y's, I'm going to do the same. 5 plus -3 divided by 2. Well, 2 plus 6 is 8 over 2. Well, that reduces to 4. 5 plus a -3, that's just like 5 minus 3, which is 2 over 2, which is a 1. So this is saying that my midpoint algebraically should be a 4, 1. Now graphically, if I plot that, that is my midpoint. And sure enough, it looks like the midpoint. It should be. Now, if you do the midpoint calculation and you graph it and it's way off the line, then you know you did something wrong. So always make sure you check your work graphically, and you'll be asked to do that on your assignment. Now, what would happen, though, if it didn't come out nice and pretty like these numbers? What would happen if it was like 7/2 when you did all the math? Well, it's always going to have a denominator of 2, right, because of the formula. So it's always going to be something. So 7½ is 3½. Or 7/2 is 3½. So you would plot between 3 and 4, if that was the case here, if that was the x-coordinate. Between 3 and 4. So it's always going to be between 2 grid marks. So don't be startled by a half or a fraction in your answer. You can still graph that. Now for class, I want you to try this one. It's another distance formula problem like we did in the first example. I want you to determine the lengths of the endpoint, the lengths of the sides, and then determine is it a right triangle. We'll start here when we get to